Hello everyone, I'm Srimayee Dastidar. My team members are Shubham Yadav, Yashraj Chauhan, and Aditya Narayan Dash. Here we will be presenting the topic Indian radar systems. So basically, radar stands for radio detecting and ranging. It is based on the use of radio waves. This concept is similar to echo. The main components of radar are the transmitter, the antenna, the receiver, and the indicator. I give over to Aditya Narayan Dash.
So before I say something about this image, let me explain radar to you very clearly. Radar, that means RA, radio, D for detecting, and R for ranging. As the name indicated, is used from radio waves. So radar sends out electromagnetic waves similar to the wireless computer network and mobile phones. The signals are sent out as short pulses, which may be reflected by object in their path, and in part reflecting back to the radar. When these pulses intercept precipitation, a part of the energy is scattered back to the radar. This concept is similar to hearing an echo. For example, when you shout to in a whale, the uh, sound waves reflect back to you. In the same case, radar works. So the components of radar: a transmitter, it creates energy pulse; a transmit or receive switch, that's called the duplexer. It tells the antenna when to transmit and when to receive the pulses, and antenna to send these pulses out to the atmosphere and receive the reflected pulse back. A receiver which detects and amplifies and transforms the received signals to video format. So as you can see in this image, there is a transmitter, a duplexer, and receiver, and there is a display unit which shows us the uh, exact location where the or any object is located. So transmitter sends signals to the duplexer. That duplexer switches to the transmitter and sends some electromagnetic pulses to antenna, and that then reflects back to the receiver, and the receiver then displays the object in the display unit. Can we go to the next slide, please? So these are common Indian radar systems: Indra 1, Indra 2, Ashwini radar, and Rohini radar. Next. So Indra 1, as the name suggests, INDRA. IN for Indian, D for Doppler, and R for radar, is operating in L-band military tactical system with surveillance 2D radar for point and area defense, or gap filler for the air defense, especially against the aircraft threat at very low altitude. The radar was developed in 1980s to meet air defense requirement if Indian armed forces, and provides range and azimuth information target accuracy. So Indra 1 uses mechanically scanning out doubly curved reflector antenna. It has high gain and fairly low side lobes. The radiating elements is a corrugated horn which supports dual polarization. The radar has integrated the radar is integrated in the main antenna IFF. So some features of the radar are it works on L band. It has track while scan system. It can identify integrate it can identify friend or foe, that is IFF. And it is very easily transportable, that is it has mobile transport. It also has high scan rate for high speed target detection. So let's go to Indra 2. So as in Indra 1, the classified keyed on and off pulse radar is distributed in 2 trucks. Indra 2 uses pulse compression and is distributed in 3 trucks. So it is connected to an air defense network using computer system via satellite and fiber optics. And it also uses microwave links. So both variants are fully transportable by rail, road, and air. So comes to features of Indra 2. It has some extra features compared to Indra 1 as it's a developed version. So it has fully coherent system, frequency agility. It can use pulse compression, advanced system processing using MTD and CFR techniques. It also has track while scanning system for 2D targets, full tracking and capabilities of maneuvering targets, multicolor PPI and raster scan display, both presenting MTI and synthetic video. It can also identify friend or foe with ease of transportation. So now I would like to say some more things that say some more things that will help you identify the Rohini and Ashwini radar. So Shubham, can you please?
So if we talk about system characteristics of am I audible?
Yes.
Yes.
So if we talk about Ashwini radar, the features of Ashwini radar, low level transportable radar. Ashwini is a multifunctional system capable of pinpointing highly maneuverable targets with outstanding accuracy. Ashwini also provides the velocity vector of the incoming target, and that is why it is called a 4D radar. It provides situational awareness against high-speed fighter aircraft at ranges of up to 200 kilometers. Next, if we talk about Rohini radar, the features of Rohini radar is the Rohini radar is a 3D multifunctional medium range air surveillance radar. Rohini can detect and track multiple targets flying simultaneously and determine their position. Its horizontal detection range is up to 170 kilometer and 15 kilometer in altitude. The Rohini radar system can detect low altitude targets as well as supersonic aircraft flying at up to Mach 3. Capable of tracking maneuver targets, it has frequency and jammer analysis. Also, a secondary surveillance radar that works as a IFF is integrated with the primary radar to distinguish friendly and aircraft. Now, I give over to Aditya Dash.
Next slide, please. So this is the specifications of Indra 1 and Indra 2 radar. So they both use L-band frequency. The pulse width is different in this case because the Indra 1 is the first version and Indra 2 is the second version. So 3.2 microsecond is the pulse width for Indra 1 and 6.6 microsecond is for Indra 2. Their peak power is 40 kilowatt for Indra 1, and for Indra 2 it's 100 kilowatt. With respect to the power, the instrumented range also increases. So Indra 1 has 50 kilometer and Indra 2 has 90 kilometer range. The bandwidth, the beam width is 3 degree for both cases, and the antenna rotation is same for both cases. That is 16 RPM. Okay. Now comes the section of Rohini and Ashwini. Frequency for Rohini is S band. Their instrumented range is 200 kilometer. The accuracy is 50 meter, and the range is 200 meter. The antenna rotations will be both same. That is 7.5 to 15 RPM. For Ashwini, the L band, it uses L band, same as the Indra radar, and their instrumented range is 50 kilometer. The accuracy is 30 meter, and the range resolution is 120 meter. So now, Srimayee, can you please explain more about the advantages and the disadvantages of the radar system?
The advantages of the radar system. Radar can penetrate mediums such as clouds, fog, mist, and snow. Radar signals can also penetrate insulators. It can target several objects simultaneously, and it can help finding out parameters like objects or targets, range, angular position, location of target, and velocity of target. It is a fast method of calculating base maps when no detailed survey is required. High operating frequency allows for storage of large amount of data, and it can tell the difference between stationary and moving objects. The disadvantages of radar are radar takes no time to look on an object. It cannot find out following parameters of objects or targets that are. It cannot track if an object is decelerating at more than 1 meter per hour per second. Radar has a wider beam range of 50 feet diameter, over 50 feet diameter. It has a shorter range of 200 feet. Radar can be interfered with several objects and mediums in the air. It cannot distinguish or resolve multiple targets, and also it cannot differentiate the color of the object. It cannot be used beyond. Next slide. Now we talk about imaging radar. So this is an image, a SAR radar image acquired by the SIRC SAR radar on the board. The space shuttle Endeavour shows the Tidy volcano. So imaging radar is an application of radar which is used to create 2D images typically of landscapes. Imaging radar provides its light to illuminate an area on the ground and then takes a picture of radio wavelengths. It uses an antenna and digital computer storage to record its imagery. In a radar image, the energy that was reflected back towards the radar antenna is visible. Digital radar images are composed of many dots. Each pixel in the radar image represents the radar backscatter for the area on the ground. Brighter areas represent high backscatter, darker areas represent low backscatter. Imaging radar attempts to form an image on one object, for example, a landscape, by furthermore registering the intensity of the reflected signal to determine the amount of scattering. The registered electromagnetic scattering is then mapped onto a 2D plane, with points with a higher reflectivity getting assigned usually a brighter color, thus creating an image. Here are some of the references. Thank you. I would like to thank Dr. Kumar and UPES for giving us this opportunity, and Space Habitat providing such a great platform to showcase our project.